Okay, so these are the topics that we'll be covering in this session. Let's jump straight in with auto grouping and geolocation data. Now, we've discussed geolocation data previously, this being the latitude and longitude data that we associate with our monitored devices and use to populate dashboard world map panels like we see here. Our original map providing data around average ping values and ping state for all devices in some remote offices. We previously covered adding this geolocation data via the primary method, a CSV data import, and now we're going to look at another method, and that's using auto grouping. Within auto grouping, I'll add a new rule. Let's say I have a new office opening up in Barcelona and I want to add geolocation data for the monitored hardware in that office. Now, I'm not going to group devices via auto grouping. I'm going to update the device configuration data, adding both latitude and longitude. So I'll leave the group field empty. I'll still employ a filter to focus the rule to the devices that I want updated. If I had a group for my new office, then I could use a group filter, or I could employ an attribute filter. In my instance, all the devices have Barcelona in the device name, so I'll just use that. Now I show advanced options and add the configuration fields that I want updated, latitude and longitude. Add the values and test the rule. So we've identified 11 devices with Barcelona in the device name, and running the rule will update the geolocation data for each. I'll run the rule. That's been processed, and we've used auto grouping rules to add geolocation data for our monitored devices. Now, the other aspect of auto grouping and geolocation data that I wanted to look at is using geolocation data to drive auto grouping. Let's say I have a new office opening in Barcelona and I want to add the monitored hardware in that office to a dedicated group. I name the group and use attribute filters to filter the rule's output. All devices in my new office have geolocation data already, so I can use their latitude and longitude to filter the devices. Add my values, test the rule, and I've found 11 devices with that geolocation data. I can run and save the rule. So using auto grouping to add geolocation data and using geolocation data to drive auto grouping. Our next item is knock screen cycling. So running a dashboard playlist on a knock screen or something similar to that. In dashboard management, I select playlists, and we can see a couple of playlists here. I could add a new one, but I'll just update an existing playlist. We see the current configuration. I'll add a new dashboard and set the order in which they'll be cycled. The interval here is duration that each dashboard is displayed before we cycle to the next. Typically you'll display each for a few minutes, but just so we can see them cycling here, I'll set mine to 7 seconds. You don't have to worry about session timeouts for playlists running on a knock screen. The act of cycling the dashboard will keep the session alive. Now, the play options. Normal mode, we just present the playlist in the standard StatSeeker UI with some playlist controls, and if I interact with the screen outside of the playlist controls, it'll exit the playlist. The TV mode is the same as the normal mode, but it will hide those playlist controls after a minute of inactivity, and any mouse or keyboard activity will show those controls once again. And the last option that we see here is full screen mode. Collapse the main navigator, hide the controls, and this is the primary play mode for something like a knock screen. Click the display header to exit. Remember, if you are using groups to limit data visibility for your users, then maybe have a dedicated knock user account with the all groups permission. So your knock screen displays everything you want, but the user session driving the knock display isn't one of your admin accounts. Okay, on to the real-time poller. This is a unique report which is available as a drill down from any of the default StatSeeker interface data reports, such as the Interface Statistics Detail Report. Any of the time series data fields we see here will drill down to a focused interface stats report for that interface. You can see here that we have a collapsed report header for the real-time poller. If I open that report, we'll begin to see details for the data going through that interface in real time, updating every second. The intention for this report is a tool for when you're troubleshooting an issue. With the real-time poller, you're getting immediate feedback on the impacts of your efforts to address whatever data rate related issue that you're troubleshooting. Now by default this report is hidden and the real-time polling of the interface doesn't actually begin until you open the report, and typically you don't want StatSeeker to be hitting the interface every second. But you can alter this default behavior from the admin tool, Network Discovery and Advanced Options, Advanced Options. Scroll down to the reporting section and we have our real-time poller settings here. So by default the real-time poller is enabled, but you can hide the functionality. If it is enabled, then you can specify the behavior for when the drill down report is launched. The default value, as we saw, was hide the real-time poller with the option to show it. But you can set it to display on launch with the option to hide, always on with no option to hide, or again, hide the functionality with no option to show. If you do update the default behavior, don't forget to save the change on your way out of this screen. Okay, next we have limiting data visibility for users, and for that we use grouping. Now it's something that we mention a lot, so let's have a quick look at that. Here, I'm again looking at that European offices dashboard that we saw, and you can see that I'm currently logged in as the admin user. I'll just open a browser looking at the same dashboard, but here I'm logged in as another user, Jack Burton. And if we compare the two, we can see that while the admin user can see all of our European offices, Jack only has visibility to a selection of the offices to the east. This limitation will be present in any dashboard or report run as the Jack Burton user. Now if I jump into the admin tool, add and edit groups, I can see which groups Jack has access to. I'll just use the toggle here, select the users, and then Mr. Burton, and I can see the groups currently associated with Jack's account. I'll search for Spain. This group should include our Lisbon, Madrid, and the new Barcelona office. Assign that group to Jack, and now refresh Jack's browser. And we see the new data coming in for the group that we've just added. Select groups to limit data visibility. Assign the all groups permission to enable visibility to all data on the server. Now the last item we have is looking at anomaly detection and its use in thresholds and alerting. So for anomaly detection, StatSeeker takes the last 6 months of your data history, and that's for every polled metric on your network. CPU loads for every device, all interface metrics for every interface, file system utilization, number of current VPN connections, 6 months of everything that StatSeeker monitors. And then from that data, StatSeeker builds a data profile or baseline for every one of those items. A profile for how every element of your network typically behaves. For anomaly detection, StatSeeker compares your current data, what's happening right now, to that baseline and measures how different the current behavior is compared to what is expected. If the current behavior is statistically different enough to be considered anomalous, and if you have a threshold configured looking for anomalous behavior, then you can trigger an alert when something unusual occurs. So let's head to the admin tool and look at that threshold configuration. For our example, we'll look at anomalous outbound traffic from our WAN links. So we're looking at outbound utilization for interfaces in our WAN links group. The format we want is anomaly metric, and the threshold value for that metric is 95. The anomaly metric is a calculated value. Any value greater than 95 is considered anomalously high. Any value lower than minus 95, anomalously low. I want to know about unusually high outbound communication, so I set a value of 95. I want to assess the threshold every 5 minutes, and I want to use the previous 15 minutes of data as my current behavior. I don't care if I get a 5-minute spike in communications, but if it's persistent for 15 minutes, then let me know. So with this configuration, every 5 minutes, grab the last 15 minutes worth of outbound utilization data for every interface in my WAN links group, compare the current behavior to our baseline data, and if that comes back with an anomaly metric greater than 95, record an event. An alternative to this configuration was introduced in StatSeeker version 554, and that's to use our baseline data directly. I'll select baseline and the format comparison and set my value to 20. We're looking at outbound utilization, and that's measured in percent. So with this baseline comparison, we now have a threshold where if our current outbound utilization is 20% higher than our baseline value, that's our expected value for that interface at that time of day, on that day of the week, then we record an event. And if an alert is hanging off this threshold configuration, we get an alert letting us know that something unusual is happening. We can take this threshold configuration a step further. What if we're setting this threshold because we had unusual outbound traffic from one or more of our WAN links and we want to be alerted in the event that it happens again? And what if this unusual behavior has been occurring regularly for some time? Now, if it happened a few times, it's no problem. The unusual behavior will be drowned out by our typical behavior when we're building the baseline. But if that behavior occurred consistently for a long period of time, it means that it might begin to look like that it is the typical behavior. If we don't want our baseline to include that unusual behavior, we can cut it out. In our configuration, we can see the baseline time range here, currently set to the default last 180 days. So let's edit that. I can use the slider or calendar controls or directly enter values for start and end date to limit the date range used to contribute to the baseline model. Alternatively, I can add an exclusion period to this data range. If these adjustments result in excluding a large amount of the previous 180 days, then to ensure we still have enough data to build a reliable baseline, we can head off to the advanced time filter editor to configure a more specific time filter. With this time filter, we get every minute of every day for the past 180 days, except for between 7:30 p.m. and 11 p.m. Thursday nights between November last year and February this year. Click Done to send that time filter back to the threshold. If we need to remove anomalous data so it's not included in our baseline history, and again, we only need to do that if it's been happening regularly for a long period of time, we can remove that by just adding the exclusion periods in the baseline history editor, or we can head off to the advanced time filter editor to build a very granular time filter if that's going to be what we need. And that's everything that I wanted to cover in this session. I'll catch you in the next one.